In today's lesson, we are going to touch on a topic that we went over a few videos ago, and that is the laws of exponents. And we're going to go over the exponent laws using a bunch of different examples. And if you find yourself having trouble solving these examples with me, then I suggest you refer back to one of the first few videos on the laws of exponents and mastering those laws. So let's start off with some easy examples. Let's say we had 4 raised to the power of 2x multiplied by 4 raised to the power of 8x. Now we have a common base in both of these terms of 4, and we are multiplying. So we know from our exponent laws that when we're multiplying and we have a common base, we're going to write down that common base and we're going to add our exponents. So we're going to have 2x plus 8x, which is going to give us 4 to the power of 10x. Now let's say we had 4x cubed divided by 3x to the power of 8. Now this example here can be written as 4/3 multiplied by x to the power of 3 over x to the power of 8. And here we have the same base of x, and we are dividing, so we know from our exponent laws that when we are dividing and we have a common base, we're going to subtract our exponents. So this is the same thing as 4 over 3 x to the 3 minus 8, and that is equal to 4 over 3 times x to the power of negative 5, because 3 minus 8 is negative 5. And we can also recall that when we have a negative in an exponent like this, that is basically the same thing as if we were to put the exponent at the denominator side, and then it would be raised to a positive exponent. And that's if our exponent already is in the numerator and it's raised to a negative power, then we can just move it to the denominator and the power will become positive. So this is the same thing as 4 over 3x to the power of 5. Now let's say we had 2x all raised to the 4th power. So the way that we would do this is, that's essentially the same thing as 2 to the power of 4 times x to the power of 4. And we know that 2 to the power of 4 is equal to 16. And so 16x4 is our final answer. Now let's say we have 8x squared y divided by 2x y cubed. So already we can very quickly calculate the numerical part here. 8 divided by 2 is just going to be 4. So we know we're going to have 4 on our numerator. And now we have a common base of x in both the numerator and denominator, and a common base of y in the numerator and denominator. So this can be simplified to 4x to the power of 2 minus 1, because the exponent here is 1. So that's going to be x to the 2 minus 1, and y to the power of 1 minus 3. And that is going to be 4x to the 2 minus 1 is just 1, so it's going to be 4x, and 1 minus 3 is minus 2. So we're going to have y squared at the bottom. And that's because if we were writing this just as it is, it would be the y to the power of minus 2 at the top, but because it's negative, we can just move it to the denominator and that exponent becomes positive. Let's go over a few more examples. Let's say we had 2x divided by 3x squared, all raised to the power of 2. So we know that this is the same thing as the numerator raised to the power of 2 divided by the denominator raised to the power of 2. So if we're going to just do that, let's raise first the numerator to the power of 2. Well, 2 to the power of 2 is going to be equal to 4, and x to the power of 2 will be x squared. And then we're going to have 3 to the power of 2, which is equal to 9. And x squared to the power of 2, which we can just multiply that in, and that's going to give us x4. And again, we can recognize that we have a common base on both the numerator and the denominator, so we can simplify this even further as writing 4 over 9, and we have x to the power of 2 minus 4, which is going to be x to the power of minus 2. So we can write that down with our x squared in the denominator. Again, because if we were writing this down with this in the numerator, it would be 4 x to the minus 2 over 9, but because it's negative, we can bring it down here and it becomes positive. Now let's say we had 3 to the power of negative 3 and raise that to the power of x plus 4. Well, from our exponent laws, we know that when we have brackets and we're raising a power to another power, that's just the same thing as writing down the space and multiplying our exponents out. So that is going to be equal to 3 to the power of negative 3 multiplied by x plus 4, which is 3 to the power of negative 3x minus 12. Now let's look at a slightly more challenging example. What if we had 9 to the power of x minus 1 divided by 3 to the power of x plus 1? Well, when you first look at this, this might not seem like something that we can easily tackle with our exponent laws. But one thing that we can notice is that if we were to convert this 9 into a form where it has the same base as this number here, it might look a little bit easier to us. So let's convert 9 into a form where we have a base of 3. And we know that 3 squared is equal to 9. So we can write down this 9 as 3 squared, and we're raising that to the power of x because we have 9 to the power of x minus 1 over 3 to the power of x plus 1. And now something that you might recognize is that this term here, 3 squared times x, is the same thing as 3 to the power of 2x, because by our exponent laws, when we have an exponent and brackets and raised to another exponent, we're just going to multiply these together. And this is exactly the same thing as 3x squared, again by that same law here. So what you might notice is that we actually have a difference of 2 squares here. This is a perfect square, and 1 we know is a perfect square. So when we're doing a difference of 2 squares, we can actually factor this as 3 to the power of x minus 1 and 3 to the power of x plus 1. And again, that's because we notice we have a difference of 2 squares. So we're going to take the square root of each of our squares and have a bracket where we add them and a bracket where we subtract them. So all we've done here is just factor this top part, the numerator, as 3x minus 1 and 3x plus 1 because this is a difference of 2 squares. And that is going to be over our denominator, which is 3 to the x plus 1. And one thing that we can now notice is that we have a common expression in both the numerator and the denominator. So we can cancel these two out, and we're going to be left with 3 to the power of x minus 1. And that is our most simplified answer.